I'm going to do a video for you for this statistics test review. I'm going to go through it pretty quickly, but if I go through it too fast and you don't get something, you can always stop, pause, rewind, and listen to it again. Number one, number of students who attend the school dance are in the chart, approximately what percent, and I'm going to pick up on the fact that it says of female students. I know that of part is going to be in the bottom, so I'm going to need the of part on the bottom, and it's of the female students. I need all of the female students. All right, so I'm going to have to add 51 plus 75 plus 71 plus 84. If you add all of those, you get a total of 281 female students. Then it says, what percent of the female students who attended the dance were in the 12th grade? So I need the 12th grade female students. So 12th grade's here, and I'm looking at 84. So to get my final one, it's going to be 84 12th grade females, and the of part is going to be 281 because those are all of the female students in the whole school. So we're talking about a part divided by the whole. If you divide that, okay, 84 divided by 281 on your calculator, all right, dividing 84 by 281, I end up with 0.298. That's a decimal. If we move the decimal over, or times by 100, we can change it to a percent, so it's 29.8%. 29.8% actually corresponds to B, 30% when we round it to the nearest whole percent. Number two, the West Oaks Dance Club. We have all of these in here. I'm noticing when I look ahead that all of these questions are 16 more freshman students, students who perform choreographed, club refreshments, so they're asking a lot of different things. So our best bet is before we get started is to multiply these percent numbers. Now remember, these are percents that have been changed to decimals. So what I want to do is I'm going to find the percent of 100. Good thing about percents of 100 is 100 is easy. So 31% of 100 corresponds to 31 students. 27 sophomores, or 0.27%, prefer freestyle. That corresponds to 27 students. And if we add those up, that's 58 total. 15% of 100 is 15 students. 27% is 27 students. And if we add 15 and 27, we get 42 students. If we add all of the freshmen total, I get 46. If I add 27 and 27, I get 54 total sophomores. And if I add 58 and 42, which is the total number of everything, I get all 100 students. So I have all of my numbers. Now that I have all of my numbers, I can figure out which one it's saying. Which statement is true? 16 more freshman students prefer choreographed than freestyle. So I'm looking at freshmen. Well, freshman students prefer choreographed. Well, it looks to me like 15 to 31 students don't prefer choreographed to freestyle. And it's definitely not 16. It's written the opposite way. A is out. Letter B, 58 students prefer choreographed. So if I go to choreographed and I come down, my total is 42. This number right here, choreographed, the total is 42. Obviously, it's not 58. I don't like choice B. Letter C, 46% of the students in the club are freshmen. Freshmen. So if I'm looking all the way across the graph to the freshmen, all the way across, sure enough, the total of students who are freshmen who are in this club are 46. I'm locking choice C. I'm going to say that is correct. And the letter D, just to look and make sure we can compare. Freshmen prefer choreographed. Freshmen do not prefer choreographed. They prefer freestyle. So choice C is correct for 2. Number 3, Tomas is trying to decide on the best possible route to drive to work. He has a choice of 3 possible routes. On each day, he randomly selects a route and keeps track of whether or not he's late. After a 4-day trial, his notes look like this. Now remember, he's trying to decide on a possible route to work. And what he's doing is he's trying to find his, we have the percents of each time. All right, I grabbed my calculator and I've typed this one in. Remember, we're talking about 40 days. So 40 days and 0.1% of the time, or 10% of the time, he was late. Well, 0.1 times 40 from my calculator, 0.1 times 40 corresponds to 4 times he was late. So 4 times he was late. 0.25 times 40, 0.25 times 40 corresponds to 10 times he was late or he was not late. So apparently he went route A 14 total times. May not need that information. 0.075% of the time he took route B, he was late. So if I correspond to that, 0.075 times 40 times he tried this corresponds to 3 times. And of course, I'm repeating 0.1 is the same as the earlier, so that's going to be 4. 0.175 times 40. 0.175 times 40 corresponds to 7 times. He was not late. Apparently, he took route B 10 times. And then route C, 0.3 times 40, 12 times. He was not late. So apparently, he drove route C 16 times. So that's my data. How many days was he late? All right. He was late 4 times on route A, 3 times on route B, and 4 times on route C. That's a total of 11 days. So 11 is the answer for the first question A. How many days did he take route C? All right. I kind of sort of tallied that a while ago. Looks like he took that route C 16 times from that total right there. How many more days did he take route C over route A? Well, he took route C 16 times. He took route A 14 times. So how many more days? 2 more days. All right. Again, having my numbers up there by multiplying ahead of time allows me to see my answer a little bit easier. How many days was he on route B and he was late? So I'm only looking for one particular part. I'm looking for route B and I'm looking for when he was late. That's going to be that number right there, and that occurred 3 times. So that answer is 3. All right. Number 4. West Manchester High School interviewed 1,500 students to determine if they prefer going to the movies, going bowling, or hanging out in the home. What is the relative frequency? Again, relative frequency is a percent, okay, but it's expressed as a decimal. Okay, if we know that, relative frequency is a percent expressed as a decimal. So I'm probably looking ahead. If I realize that that's what that is, I could probably discount choices C and D immediately. So please keep in mind relative frequency is going to be a decimal. This says, what is the relative frequency of freshmen in the survey? I think that means is if 275 freshman ballots were collected. So I have 275 freshmen, and remember that's the part we're interested in, and the whole amount is 1,500 students that were done altogether. So if I divide, I'm looking for the percent, which would be expressed as a decimal. So I would simply divide 275 divided by 1,500, and my answer is 0.1833, which apparently is choice A. Again, knowing what relative frequency is allowed me to narrow my choices immediately to 2 answers instead of 4. Number 5, if you were going to open a lemonade stand on your street, what would be the best measure of data? This is a review of median, mode, mean, and range. Mode is the number that occurs most often. It's actually my answer. I would want to be on roadside with my lemonade stand active and ready to sell lemonade when I would have the most number of people driving by that could, or walking by in cars that would actually stop and buy some lemonade. Median is the number in the middle. Doesn't really help. Mean is an average. I don't really want to be out there when it's just an average because there's going to be low times and high times. I want to be out there when I have the most. So because mode is the word that refers to the number that occurs most often, that would be the mode word that I'm looking for. All right. Number 6. Table below shows a population of several cities. These are all several cities. What would happen to the data? This is one of those where I'm going to put my data in order and see if it forms a pattern. This is when we were talking about standard deviation and the normal curve. So I'm going to put them in order. And I'm noticing everything's in thousands. So if I just take off 3 zeros, I won't have to write so many zeros when I write them down. So I'm just going to realize that the number's in thousands. I'm going to use the other numbers. So it looks like it goes from 15, and then 23, and then 25, 28, 35, and 40. So I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, I've got all my numbers represented. Let's just assume that there's a normal distribution. I didn't mean to really make a curve there. Okay, so this is not my normal bell curve. Remember, normal bell curve goes up, comes back down. Okay, it's got a hump in the middle, kind of like wings on the ends. What would happen to the data if Tinkerton, with a population of 50,000, was added to the data? Well, obviously, if I discount the 3 zeros, just like I did here, I'm talking about adding the number 50. 50. It's kind of like on a test. If you know that you average somewhere in the middle, so we're probably averaging somewhere in the 20,000 range for the number of population of cities. But if you add 50, or if you add a really high number, that's going to shift your mean this way, and it's actually going to extend your range. So it's almost like you take the string. This is a good analogy. Take the string, it's going to move your mean over here, and it's going to pull it more that way. It's not going to be quite as high, but also the mean is going to shift over. So instead of being in the 20s, we're probably going to be somewhere in the 30s, because now we're averaging a much higher number in our MIST. So it says, what would happen to the data set if Tinkerton, with a population of 50,000, was added to the data? So we've discussed it. Let's see which one of these matches. The standard deviation decreases. Remember, standard deviation is the spread of the data. If we add a number that was outside of our range, I only went from 15 to 40. Now I'm having to spread out a little more to accommodate 50. So obviously, standard deviation increases, not decreases. Interquartile range kind of goes back to the 5-number summary. Interquartile range is always Q3 minus Q1, the inner box numbers. I don't have that kind of data, so it's probably not going to be that one. The mean increases. My mean, we said, probably started in the 20s, probably is now bumped it up in somewhere in the 30s. That definitely is going to happen. All right. Does the range decrease? Remember, range is the highest minus the lowest. Well, in the beginning, I was going from 15 only to 40. Now my range is going from 15 all the way to 50. So my range actually got more. My range actually increased, not decreased. So since that was obviously not the case, it confirms C is the correct choice. Number 7, the table shows the area of several states. Iowa has an area of 57,000, which is not true of the data in Iowa. I'm going to do the same thing I did a minute ago. I'm going to put all these in order. So I'm going to put 9, it's like 11, 12, oops, forgot 6, so squeeze 6 over here. Ooh, got a bunch of 40s. 46, actually a bunch of 54, 54, and 59. Ain't no way that data's very even. We'll just represent with a bell curve. We just need an idea of how this thing is going to change. Okay? Iowa has an area of 57,000 square kilometers, and all of these numbers was in thousands. So it's almost like I just need to do 57. So I'm going to be adding a number right there, which is not true. Let's make sure we realize that. This one is saying which is not true. Remember, imagine the blue line being on a string. You're averaging a number in that's above where the middle used to be. Okay? So it's actually going to pull the string, it's going to pull it a little bit lower, and it's going to move it over here. Now the average is going to be a little bit, probably a little bit higher, like right there. So it's going to increase some things. Does the mean increase? Sure does. I'm going to average a higher number. Does the range increase? The range goes from 6 all the way to 59. So it went from 6 to 59. When I added 57 in here, did the range change? Still went from 6 to 59. 57 is in front of 59, so it's not pushing my range out. I don't think my range increased. I think my range stayed the same. So I think that one stayed the same. I don't think that one increased. I think that's going to be the one. Does my interquartile range increase? Well, it kind of makes sense that if the range gets shifted, If I had a box and whiskers, it would make sense that it would probably shift to the right as well. Does my standard deviation increase? Standard deviation probably does not, or probably does increase. So that actually makes a little bit of sense. Which one is not true? The one that turns out to not be true is letter B. All right. So B stays the same, so obviously it's the one that's not true. Number 8, the points scored in a basketball game. I'm going to order the data like we've done before. So these are points that we scored by the team. So this is not individual, this is team. So the lowest point total we had in a game was 45. Then it would have been 48. Then it would be, see, 52 maybe, 52, 57. Then it would be 58, 60, 63, and 71, 72, and then 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data points, 10 numbers in order. What would happen to the data distribution? So here's my original data. Remember, we're going to represent it with a bell curve. This is just a good way of doing it. What would happen to the team if we scored 72? So we'd have another 72 here. 58. 58 is going to be right here. Okay. 46. 46 is right here. And 85 in their next game. Ooh, 85. That's a high. That's higher than any I have. So 85 pushes me on the outside edge. Okay. What would happen to the data distribution? Which one of these makes sense? The standard deviation would decrease. Remember, standard deviation is how much it's spread out. Well, if I have to push my standard deviation or push my graph to include 85, that's going up bigger. So I'm actually going to spread it out more. So this would be more. This would be increase. So obviously, A is not out. The range would increase. The range would increase. What was my original range? My original range was the low of 45 to original of 80. So it would be 45 to the high of 80. Now I'm having to do what? Still low of 45, but now I'm going to a high of what? 85. My range did increase, definitely. I believe he is the answer. My mean would increase. Well, it's hard to tell if the mean would increase a lot, and here's the reason. I actually added 46, so I pulled the mean back. I added 58, which is going to pull the mean back. I added 72, which would push the mean up. I added 85, which would push the mean up. So I've got data that's pushing the mean up, but I've also got data that's pushing the mean back down. Probably the mean would not increase or decrease tremendously. It would be hard to predict in this particular set of data. We already have a good answer with B, and I think that is your best answer. All right, actually I know it's the best answer. Number 9, the number of points scored by a basketball player. All right, here we go. Same thing again. Let's just look at it. What is my lowest one? We've done this a couple of times. My lowest one is 15. He's a basketball player. He said 15 points, 16 points, 18 points, 21 points, 25 points, 30 points, 32 points, and 35 points. So this kid has had some tremendous games. Then all of a sudden it says, what would happen to the data? Imagine the data. Okay, has a normal bell curve. What would happen to the data if you had 4 points and 8 points? We had an injury. We got a lot of fouls this game. We weren't able to play the game. We got sick or something. That's going to pull our average way down, isn't it? Okay, so now my average is going to be slid backwards. Instead of having an average probably somewhere in the 20s, now my average is going to probably be pulled back down somewhere in the teens. Okay, just as a rough estimate. The data distribution would become less peaked and more widely spread. Well, that's true. It's probably not going to go up as high. It's almost like you're pulling on a string. Pull the blue on a string and pull it out with the red. So the red's not quite as high as the blue was. Less peaked is good. Is it more widely spread? If you have to slide all the way back to 4, you're spreading out to the left even more than before. So I think A looks really, really good. It matches what we think would happen if you had 4 points and 8 points averaged in. The following are prices for ugly sweaters. This is the 5-number summary that I think you got to know. 5-number summary. And that's exactly what we're doing in number 10. Don't have a lot of extra room, but I'm going to take my time and do my things. The following data are prices for ugly sweater. We're going to put them in order. We're going to put 45, 60, 68, 75, 76, 85, 85 again, 97, 100, 125, and 125s again, and 125 3 times, and 130. I think I have following prices for ugly sweaters. We got 2, 4, 6, 8, 10, 12, 13 sweaters. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 numbers, and that's a 76. All right, what is my mean? My mean is where I take the numbers and I add them up and I divide by however many I have. So I need the total, and then there are 13, so I'm going to divide that total by 13. So if you take the time, and my calculator's out. If you take the time to add 97 plus 85 plus 68 plus all the way across, you should end up with a total of 1,196. And if you divide that by 13, your mean should be 92. So the first answer for A is 92. All right, the median. The median is the number that occurs in the middle. And if you have 13 things, there will be, that's an odd number, there will be something directly in the middle. So I'm just going to start kind of marking off 45 and 130, marking it off, marking it off, marking them off until I get my way to the middle. This is one way to do it. 85 is right in the middle. 85 is my median. 85 is actually going to end up being my Q2 because that is the true median of all of the data. All right, mode. Mode is the number that occurs most often. We already have 125 that occurred 3 times. 125 is the number that occurred most often. The range. The range is the data, is the high minus the low. So if I do 130 minus 45, my range turns out to equal 85. Now, for the last one, I need the IQR, which means I need the median for the left-hand half and the median for the right-hand half. So if I do the median from here to here, okay, the median from here to here, I'm going to do 1, 2, falls right in here. So Q3 is going to be 125. It's between 125 and 125. All right, same thing here. I'm not counting the middle. I'm counting the ends. I'm looking at this left-hand side. So I'm going to count this one and this one. This one and this one, this one and this one. I'm right between 68 and 75. So if I add 68 plus 75, I think I end up with 143. And if you divide 143 by 2, you end up with 71.5. 71.5 turns out to be Q1. All right? So Q1 is 71.5, Q2 is 125.5. The IQR is always Q3 minus Q1, so 125 minus 71.5 gives me an IQR of 53.5. All right, that's my IQR. Remember, if the median falls between 2 numbers, you simply have to average the 2 numbers. And that's what I did to get Q1 right there. All right, that is truly your 5-number summary. All right, I'm going to erase just a little bit so that I can have a clean slate. And now we'll take another fresh look at number 11. The table below shows the number of tickets sold to each group for 2 movies. We have adults, children, senior citizens, movie Y, movie Z. Approximately what percent of the ticket sales? It doesn't say ticket sales of children, ticket sales of adults, or ticket sales for movie Y or movie Z. Of the ticket sales. So that means I need a total. I need a total of all the ticket sales. Now, that's going to end up being the bottom number. So when you do your division, the of part is what goes on the bottom. So I need all the ticket sales. So I'm going to add up 80 plus 35 plus 24. And that total adds up to 139. For movie Z, if I add up 115 plus 6 plus 32, that adds up to be 153 total tickets. Now, if I add them up together, 139 plus 153, that adds up to be 292 total tickets. So my bottom number over here is going to be 292 total tickets. Now, I have to keep reading. It says, senior citizens to movie Z. Senior citizens saw 2 movies. Some of them saw movie Y, some of them saw movie Z. So the one I'm looking for is the senior citizens who saw movie Z. So I'm looking for 32 that met the top criteria. That's the part that I'm looking for out of the whole amount, 32 divided by 292. If you divide, and my calculator is turned off, so if you divide, I got 0.1095. Move the decimal over 2 places. That's the same as 10.9%, or rounded, that's 11%. Choice B is my correct answer for 11. Number 12, box plots. For competing manufacturers, brick manufacturers, a contractor needs to buy bricks that are as close to 2.5 inches high as possible. Now that kind of means that not only do we want it to be 2.5, but we would like our bricks to be uniformly 2.5. So notice that to the range, the IQR. This is like Q1, and this is like Q3. This is always Q2 in the middle. This has got a wide range. Whoever Camille is, when Camille's bricks and Adam's bricks are being made, looks like there's a wide variety. That could be almost an inch or so difference between the size of the bricks. That makes it really hard to put them together. So if I want them as close to 2.5 as possible, it looks like Daniel's bricks are as close to 2.5 with not as much variable. So Daniel's bricks is the best that I would buy if I was looking for the criteria of having 2.5 inches as close as possible. The movie theater recorded tickets sold daily for movies during the month of June. This is a box and whisker. Let's just review. This is where our 5-number summary goes into play. 1 is the lowest value, 9 is the highest value. Notice that it says these are tickets sold in hundreds. So 1 would be 100 and 9 would be 900. Then I have a box. So box is made out of Q1, Q2, and Q3, where Q2 is the true median of all of the data from the beginning to the end. So from 1 to 9, Q2 is in the middle of that group. Q1 comes from the left-hand half, and Q3 comes from the right-hand half. Okay. The second quartile is 600. Second quartile is Q2. Q2 is 400, so obviously A is not it. The mean of the attendance. Now, when I do my 5-number summary, I'm always using the word median. So mean is not the word I'm looking for. It probably means B is out. The range is the high minus the low. Well, the lowest is 1 or 100. The highest is high, which is 900. So I need 100 to 900. So that's the reason C is not it either. Got to be D. And sure enough, when we split our numbers from the beginning to Q1, I am splitting it, and that's where 25% of all my data falls. From Q1 to Q2, that's the second quarter, or that's the next 25%. From Q2 to Q3, that's the third 25%. And from Q3 to the end, that's the fourth 25%. And so that's why D is obviously the best choice. All right, keep going. 14. A whitewater raft can only hold 1,000 pounds. What would be the best measure of a people's weight to know if an entire party can go on the whitewater trip? If I was going to estimate and I had people in the raft, the best thing I might do is I'd say, well, we're all about the same size, so let's say we're all about 150 pounds apiece, or we're all 200 pounds apiece. Then you're kind of sort of saying, okay, we've got 6 people in our group. You'd probably multiply by however much you think the average person is, and then you would find multiply and estimate. In that case, you're kind of thinking about an average, and if you're thinking about an average so that you can estimate, you're looking at the mean, because another word for the mean is the average weight of each person. Not the lowest person, not the highest person, but about what the average person in your group weighs. Okay? 15, a box plot is shown below. Which set of data can be represented by the box plot? I have to do a little bit of work on this one to try to make sure. I know that 1 is my lowest, and I know that 10 is my highest. So I know that I have to have a 1 and a 10. All right, right away I see C does not have a 1. C is obviously not going to be part of my answer. Next thing I know is 4 has to be Q2, or 4 has to be what? The true median. That means it's the middle number. Okay? 1, 2, 3, 1, 2, 3, 4's in the middle, 4's in the middle. More here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. You'd think I could count, couldn't you? Trying to find the median. Okay, 4's in the middle. Should have taken me that long. And then I have to check my 5-number summary. In the middle of this first half of the data, it's got to be a 2. So between here and here, 2's in the middle, and 2's in the middle. So far, A and B look good. All right, my Q3, that was Q1. Q3 is going to be 7. So 7's got to be the number of the second half. Well, that one works there. Doesn't work here. So now I know B is out. I need to check, is 2 from here to here? Yep, 2 would fall right there, so 2 is it. If I do this, nope, 7.5 turns out to be, that kind of tells me A is going to be the right one. When I started checking my median, my Q3 actually fell between 7 and 8. So when it falls between, you've got to average. And the average between 7 and 8, the middle of those two would be 7.5. So that's why D is not going to be. So when I check my 5-number summary, A is the best choice. 16, people below are ages of people on a playground. Now this is just a matter of counting number of pieces of data. All right, let's just check. This one says below 3. It looks like, if I'm reading it, the amount of people looks like I should have 3 people that are below 3. Well, I only have 2 people that are below 3, because 3 should be in the next little bar. So I'd say this one's probably not it. Okay, let's check the next one. Let's check B, I guess. Okay, let's check B. Here's my data up at the top. It says below 4. Below 4. So now I'm looking right here. Looks like there are 3 numbers that are below 4. And yet I'm not quite to 3. Looks like I'm at 2.5. I don't think B's it. Let's check and see if we have another option. Below 4. This one has 0 below 4. Obviously that one's gone. Okay, C. Okay, below 4. I'm right at the 3 mark. That looks good. So looking like D is probably it. I'm going to say D's it because, again, take a close look at B. Obviously, we were a little shy of being at 3, and you can't really have 2.5 of a data point. Okay, let's just verify. Between 4 and 5 looks like we're at 7. So how many points do we have between 4 and 5? 1, 2, 3, 4, 5, 6, 7. Sure enough. Pretty comfortable. Feel very confident that D is the correct choice on this. I hope this helps you prepare for the test tomorrow. I think this can be a good test. I just hope you take time to take the material in, and good luck with it.